In this video, we are going to do the Transformers movie. But of course, we'll be transforming numbers from radical to exponential. So come on!
This is Aguila, and welcome to Aguila.
Radical expressions consist of the following. First, radical sign. This is the symbol which indicates roots of the number. So this is how a radical sign looks like. Next, we have index. This is the small number which indicates the order of the radical. So example, we have that small number 3. That is the index. So it tells us the order of the root. So meaning, if we have that 3, meaning we're going to extract the cube root or the third root of the radicand. Note that if the index is omitted, it is understood that the index is 2, meaning you cannot see that small number in that place, meaning the index is 2. Next is the radicand. Radicand is the number expression inside the radical sign. Example, in this case, ab squared, it is the radicand. All of that is the radicand. Radical expression is an indicated root of a number or an expression. The expression that you see on the screen, that is read as the nth root of a. So for example, if n is equal to 2, we read that one as the square root of a or the second root of a. If n is equal to 4, then we read that as the fourth root of a, and so on. All numbers with rational exponent can be expressed in radical form, and that will be the focus of this tutorial video. So example of a radical expression, we have square root of 4. As I said earlier, since you cannot see that small number, the index, understood that the index is 2. That's why we read it as the square root. That is the usual. But you can also read it as the second root. But what is conventional is the square root of 4. Another example is this one. We read this one as the cube root of 27 because our n or our index is 3. Now let us proceed to the main focus of this tutorial video. Transforming exponential to radical. We are going to follow this procedure. If m over n is any rational number, we are referring to the exponent, which is a rational number, where n is not equal to 0. Again, n cannot be equal to 0 because division by 0 is not defined in mathematics. So if we have this form, a raised to the power of m over n, take note that the exponent is a rational number. This is how we are going to transform exponential to radical. You watch closely what will happen. Okay, that's it. So observe that the denominator of the rational exponent becomes the index, while the remaining a raised to the power of m becomes the radicand. The denominator of the rational exponent is the index when transformed into a radical expression, and that's very easy to follow. So for you to clearly understand what I presented earlier, let's have example. Write 2x to the power of 2/3 in radical form. So before you are going to start, you analyze the given. 2x to the power of 2/3. It is very clear that the power 2/3 is just for x. That's very important because if we want to transform from exponential to radical, we should know what factor has a rational exponent. So in this case, only x has a rational exponent. So meaning x to the power of 2/3 is our only problem. We want to transform that into radical. So for our solution, we just copy 2 because 2 doesn't have a rational exponent, right? And then, since you want to transform that into radical, we need a radical sign. And then, always remember what I said earlier. The denominator will become the index. That's why this denominator becomes our index 3. And then what is left is x squared. So that x squared will become the radicand. And that's it. You are done. Let's have a variation of that example. Write the quantity of 2x raised to 2/3 in a radical form. You take note of the difference between the two given. In this second example, the whole of 2x is being raised to 2/3. So it's very clear that it is not only x but 2x. So to do that, we need to have a radical sign. Unlike on the first example, 2 is excluded in the radical form because it is not being raised to a rational exponent. But in this case, it's very clear because you have that parenthesis, meaning the whole of this is being raised to 2/3. So we have a radical sign, and always remember, the denominator will become the index. That's it. And then, the remaining, we have 2x raised to the power of 2. But be careful, because we are not going to stop on this part. We need to simplify the radicand or what is inside your radical sign. So we just copy the equal sign and then the index. And then we are going to apply power of product, meaning we are going to distribute the power to each of the factor. So we start with 2 squared. 2 squared is equal to 4, and then x raised to the power of 2, that is equal to x squared. And that's it. Next example, we just call it example 2, even though we have 2 examples earlier. Write quantity of 5a cubed b squared raised to the power of 2/3 in radical form. So this problem is still very simple. If you look at the given, the whole of this 5a cubed b squared is being raised to 2/3. So we start with a radical sign, and then observe that the denominator is 3. So that will become our index. The remaining, just copy 5a cubed b squared raised to the power of 2. And the same with the previous example, we need to simplify the radicand. So that will become the cube root of 5 squared is 25. Then apply power to a power. 3 times 2 is equal to 6. So we have a to the power of 6. And then 2 times 2, that's why we will have b to the power of 4. And that's it. We're done. Let us have the reverse process from radical to exponential form. In doing that, the index is the denominator while the exponent is the numerator. What we are referring to exponent here, it is the common exponent of the radicand, especially if we have a lot of factors in our radicand. So to illustrate, if this is our radical expression, to convert to exponential, we get the radicand, and that will become our base of our power expression. And then take note of this, the index is the denominator. So we look at the index, which is m, that will become our denominator. And then since in our radicand we only have a, automatically the exponent of a will become the numerator. So from this radical form to this exponential form. So let's have example. Write the fifth root of xy squared into its exponential form. So first, in order to do this perfectly, you look at the given. The fifth root of xy squared. And then you look at the radicand. The exponent of x is 1, the exponent of y is 2, meaning there is no common exponent. So if that will happen, it's very simple. You get all of this, the radicand, that will become our base since there is no common exponent. So that will become our base. And to make it more beautiful, we enclose that one in a parenthesis. And then start with our magic. The index will become the denominator. Since the index is 5, that will become our denominator. And then, since there is no common exponent higher than 1, then that will become our numerator. Again, if there is no common exponent, automatically our numerator is 1 because exponent 1 is common exponent. And that's it. Let's solve the variation of that problem. Write the fifth root of x squared y squared into its exponential form. So you look at the difference. In this problem, the radicand is just xy squared. In this problem, the radicand is x squared y squared, and it's very clear that exponent 2 is common. So to do it nicely, we transform this radical form into this radical form. We factor out the common exponent because that is allowed. That's the reverse of the power of a product. Instead of distributing the power to each of the product, we reverse the process, and that is allowed so that we can clearly see that the two factors in our radicand has a common exponent. So after doing that, we can now proceed safely. We get xy, which will be our base, and then to make it more beautiful, we put parentheses first, and then the horizontal bar for our fraction, and then again the index will become the denominator, and then we get the common exponent, which is 2. And that's it. Second example, write the cube root of 11x squared into its exponential form. Okay, you look at the given 11x squared. Our radicand is 11x squared. It's very clear that the exponent of 11 is 1. It's invisible. The exponent of x is 2. So there is no common exponent other than 1. So we copy all of this, the 11x squared, and that will become our base. Again, to make it more beautiful, we put parentheses. Of course, that is not the purpose, but our purpose of putting parentheses emphasize that we are going to raise all of this into a common exponent. And you look at the index is 3, so that will become the denominator of our rational exponent. And since there is no common exponent, automatically it's 1. And that's it. Last example. Write negative 29, the square root of 4n over m to the power of 5p into its exponential form. As I read it earlier, negative 29 is not the index. I said earlier negative 29 the square root, right? So negative 29 is not the index, and it is not included also in the radical notation. So we can start by writing negative 29 because we don't need to transform that into exponential form. Now, you look at the radicand. 4n over m to the power of 5 and p. Common exponent is just 1 for our variable. So, it means we need to copy everything. So, copy everything. We have 4n over m to the power of 5 p. And then, we enclose that in parentheses to make it more beautiful. And then, we draw the horizontal bar for our fraction. And then, we are all and then. You look at the index. We cannot see any number on the index. Meaning, as I said earlier, if the index is omitted, it means that the index is 2. So, meaning, our denominator is 2. And then, since there is no common exponent among our radicand, automatically it's 1. And that's it. If this video helped you, do not forget to like and comment below. Thank you.